Chemistry, chapter 20, theory 6. Now we'll have a look at the standard hydrogen electrode. The standard hydrogen electrode is one of several types of half cell that can be used as reference electrodes. So now I told you earlier that we will be comparing the values of that we obtain in one electrode with another, because we can't directly measure the electrode potential of a electrode by itself. So we have to compare them, so we have to connect them. So the standard hydrogen electrode is one such electrode that can be connected with another electrode to find out the E value. So basically this is the setup. The diagram shows, figure 20.5 shows the setup of this standard hydrogen electrode. What happens is there is a H plus some acidic environment with a concentration of 1 mole per cubic decimeter. That's the standard concentration. Then in it there is a glass bell with a hole in it for hydrogen to bubble out. So as you can see, there is a hole here, right? So there is a hole there. So that is for hydrogen to bubble out. Then there is a platinum electrode connected with a platinum wire, as you can see here. This is the platinum wire and this is the platinum electrode. So now there is a supply of hydrogen gas at a pressure of 1 atm. From the top, hydrogen gas is supplied into it at 1 atm pressure, right? So that the hydrogen gas will bubble out from the inside. So what happens is there are some properties that a standard hydrogen electrode should have. We will discuss them in detail. So there is the requirements. Basic requirements are, it is made up of hydrogen gas at 1 atm or 101 kilopascal pressure in equilibrium with H plus ions of concentration 1 mole per cubic decimeter. So that is the main requirement. So the gas is bubbled, gas is supplied or pressured into the chamber from the top. Then it is in equilibrium with hydrogen H plus ions in the solution, right? Then platinum electrode is covered with platinum black, and it is in contact with both the H plus ions as well as the hydrogen gas. So that is the most important point here, because there should be an equilibrium existing between H plus and hydrogen gas, and to facilitate that you have platinum electrode in contact with both of them, the H plus and the hydrogen gas. The platinum black is finely divided platinum, which allows close contact of hydrogen gas and H plus ions in solution, so that equilibrium between H2 gas and H plus ions is established quickly. The platinum electrode is inert, so it does not take part in the reaction. So that is that is something that is really essential, because the electrode cannot take part in the chemical reaction. Standard electrode potential E standard values for all half cells are measured relative to this electrode, right? So the standard values are measured relative to this electrode. That is, the other iron and metal half cells are, or electrodes are connected to this half cell, the standard hydrogen half cell, and from there the E standard values for different half cells are calculated. So the half equations for hydrogen electrode would be the formation of H2 and then the vice versa, that is hydrogen becoming H plus, right? So that is also something that you must remember. So this 2H plus 2E giving H2. So that is and the reverse reaction you have to understand and remember. All right. So that can be actually represented with the half values as well. That is half of H2 by taking simply H plus. It doesn't actually relate to the value of E standard value, right? The equation does not affect the tendency for the element to gain electrons. So that is that is the reason behind that. Let's write a note on that. Standard hydrogen electrode. This is a reference electrode that is connected to other half cell electrodes to measure their E standard values. Pause the video and draw figure 20.5 and then write down. The electrode consists of hydrogen gas pumped from the top of the bell tube at 1 atm within brackets 101 kilopascal pressure. Next point. H plus ions of concentration 1 mole per cubic decimeter should be present along with a platinum electrode in close contact with hydrogen ions in solution as well as the hydrogen gas being pumped in. When connected to another half cell, the value read on the voltmeter gives the E standard value for that half cell. Next point. The half equation for hydrogen electrode is 2H plus aqueous plus 2E minus reversible sign H2 gas. I hope you understood this. If you have any questions, please raise them.